Here's a box. It's at rest. And according to Newton's first law, it wants to remain at rest. Remember, objects at rest will remain at rest unless acted on by an unbalanced force. I'm going to now be the unbalanced force. And the box accelerated. It went from being at rest to being in motion. Here's another box, box B. This box is also at rest. And just like box A, this box wants to remain at rest as well. Remember, objects at rest will remain at rest unless acted on by an unbalanced force. Once again, I'm going to be the unbalanced force, and I'm going to use the same exact amount of force that I put on box A. 3, 2, 1. Same force, both boxes were at rest, but very different results. So now it's time for the big reveal. What was the difference between the two boxes? They looked basically the same. However, they both had different masses. Let me show you what was inside box A. You'll notice that there are a bunch of bricks inside box A. No wonder that when I pushed it, it didn't change its speed by very much. It had very little acceleration. But then what's inside box B? Well, I still filled box B with something as well, but I filled it with a bunch of tissues. So even though the boxes had the same volume, their masses were very, very different. Box A, the one with all the bricks, had a much bigger mass than box B, the one with all the tissues. So what could we learn from that? Well, box B, the one that was filled with the tissues, may have had a very little mass, but it had a big acceleration. It changed its speed very, very quickly. That's partially the reason that it went flying off the table. So we can say that if the mass of an object is lower, for example, box B, which had very low mass, then the acceleration of the object will go up. So, an object such as box B, filled with tissues with very little mass, would have a very big acceleration. And box A, filled, as I showed you, with a bunch of bricks, has a very big mass, and therefore it would have a very low acceleration. These were significant discoveries back in the time of Sir Isaac Newton. Now you may recall, we just talked about Newton. Newton was the one who was responsible for developing his first law of motion, otherwise known as the law of inertia. In that law, Newton said that an object that was at rest or an object that was in motion would continue doing what it was already doing unless it was acted on by an unbalanced force. And that's what happened in our example. Both of those boxes were at rest. They wanted to stay at rest, but I provided an unbalanced force that caused them to accelerate. But here we're going to move past Newton's first law a little bit, and we're going to now take a look at Newton's second law of motion. Which basically states what I just told you. The fact that as the mass of an object goes down, its acceleration goes up. Now that's only true if the force is the same. For example, imagine I put the same size engine in a really heavy truck and a really small car. The small car would pick up speed very quickly, It would be able to get maybe from 0 to 60 in only a couple of seconds. But that big truck, it would take a long time to reach its top speed. So even though both cars still could get up to a very big speed, it would take the big truck a much longer time because it would have a lower acceleration. Car with the smaller mass would have the bigger acceleration. But my friends, this is only half of Newton's second law. Now we just saw that if the mass is changed, that the acceleration will change. But what about the force? Earlier, I made sure I kept the force the same. Now, I'm going to keep the mass the same. I'm going to only use box A, the one with the bricks inside of it. And I'm going to start off by using a very small force on box A. It's still an unbalanced force, so I'm going to get box A to change its motion and go from being at rest to being in motion. But it will not have a very big acceleration. Have a watch. Small force, very small acceleration. But what if I increase the force? What if I use a lot of force? Well, box A will certainly not stay at rest once again. But this time, box A is going to pick up speed very, very quickly. And we should see some dramatic results. Let's have a watch. I'm going to use now a big force on box A. 3, 2, 1. Well, the bricks survived, but as you could very clearly see, if I use a bigger force, then the acceleration is dramatically bigger as well. So, keeping the mass the same reveals the second part of Newton's second law of motion. And that says that if the force increases, then the acceleration increases as well. So, if you want an object to change its speed very quickly, or in other words, you want an object to have a very big acceleration, you should do two things. You should make the mass of the object as small as possible, and you should make the force on the object as big as possible. And these two facts combined represent Newton's second law of motion. Essentially, what the second law says is that as the mass decreases, the acceleration increases. And as the force increases, the acceleration increases. Mass and acceleration would have an inverse relationship, as demonstrated by the mass going down and the acceleration going up. Force and acceleration would have a direct relationship, because as the force goes up, the acceleration goes up as well. You will learn about 3 laws of motion that are attributed to Isaac Newton. The first law says that an object at rest will remain at rest, and an object in motion will remain in motion, unless acted on by an unbalanced force. The second law says that as the mass decreases, the acceleration increases, and as the force increases, the acceleration increases as well. We'll learn about the third law in the coming days, but thanks for watching.